We're graphing the parent functions of exponentials and logarithms, but I chose to specifically use a base of 2. What do we know about exponentials and logs, though? They're what of each other? Which is called inverses. They're inverses. So when we did inverse functions, we know that our x's become our y's and our y's become our x's. And then when we graphed this yesterday, we noticed that the characteristics were also opposite of each other. So our domain became my range, and my range became my domain, and vice versa with the intercepts and asymptotes, because you're switching your x's with y's. Okay, why did we have an asymptote, though? Let's go back to exponentials. Do we remember what the negative exponents did to our outputs?
When did we get that paper?
Yesterday. Okay, well, here's your recap. Negative exponent means that it's a reciprocal. So you're supposed to put it at the denominator, and then it becomes a fraction. It's 1/2. And then when I did -2, it became 1/2 squared, a fourth, which is smaller. And then -3 became an eighth, which is even smaller. And then -4 became a 16th, which is even smaller. So the further negative I go, what's happening to my outputs? You're getting closer to 0 because they get smaller and smaller. But will they ever be negative? No, because they're still going to be written as a fraction. Like we could write something crazy like this, and it's still really close to 0. So that's why we said for exponentials, as this black line right here, that's the exponential graph, as it goes to the left for our x's, they're approaching that yellow asymptote, which is y = 0. And then as they go to the right, as x's go positive, what's happening to the outputs then? As the x's get bigger, then what happens to the outputs? They get bigger and increase and go towards infinity. So we know that we have the asymptote, but with logs, it's kind of the opposite. So were we ever going to get negative outputs for exponentials? No, we got fractions. So then if I can't have negative outputs here, can I have negative inputs here? So for logarithm, that's why they have an asymptote on the blue line at x = 0. Because you can't plug in a 0 or a negative. Why? Because with exponentials, you won't get 0 or negatives. That's why you have an asymptote at x = 0 instead of y = 0. Okay, questions on the parent functions, though, on how to graph them. I'm sure you guys could figure out the domain and range for those of you that were absent. All right, so when we talked about transformations, the same transformations as we've done all year long with a, h, and k, the parent function is just the log with whatever base is specified. So right here, log base b of x. That would be the original function. A is being multiplied to it, and it is a transformation. These would be the transformations for a. H is whatever's inside with your x value, but remember, we always do the inverse of what's changing x because x isn't by itself. Sebastian, are you going to wake up? Okay. And then k is on the outside, which causes you to shift up or down because it's adding or subtracting to your inputs. But remember, the b is only there because you can have whatever base. The parent function uses whatever base is specified. Same with exponentials. With exponentials, this is the parent function, b to the x. It can have whatever base. But if you have an a in the front, an h with the x value, or a k on the outside, it's going to transform that parent function. Okay, so get the second page out. We got started on this yesterday. We went and graphed this function on the back side and specified all of the other things. Let's go and do a few more. So remind yourself the exponential looks like this as a parent, and the logarithm looks like this as a parent. Okay, so let's go specify a few more transformations. Let's look at number 1. Can you guys tell me what the parent function would be for number 1 with no transformations? Is this an exponential or a logarithm? Exponential. So the parent function is whatever the base is to just the power of x. So what's the parent of this one? Y equals what? What is the base? 2. So the parent for this one is y = 2 to the x, which means I got some transformations. If you look at your other piece of notes, do we have an a value in front of the base? 2 is the base. So do we have an a value being multiplied to the base? Then I did not reflect, stretch, or compress. I didn't do any of those. Do I have an h value that's changing my x? Yes, but remember we always do the opposite since x isn't by itself, so we need to inverse that. Sergio, wake up. So how do I say that the plus 3 is changing my x's? It's going to do what? X's do what? They go left and right, but it's the opposite, so it's going to translate where? Left 3. Okay, the minus 1, is that changing the x? Is it inside the exponent with the x? No, then that's your k value, where you're adding or subtracting to your output. So your k is going to shift you up or down. So if it's minus 1, we shift down 1. Okay, question on listing transformations for number 1. All right, let's do number 2 the same way. What's the parent function for number 2? Y equals what? To the power of x. So then all those other values are the transformations. Do we have an a? Yes, the a is 3 because it's being multiplied. What happens when you multiply the height by 3? It causes you to what? Stretch out. It's a vertical stretch because it's bigger than 1. Okay, do we have an h value? What is it? 2. And we always inverse what's changing x, so this is going to translate. Don't be that person that's just copying notes and not listening to the words coming out of my mouth. Exactly.
Well, so we're pretty much just doing, like, putting everything that we've done together.
What do you mean? I mean, yeah, it's the same repetition as what we've done before. It's just with these functions. So you should already know a, h, and k because we've done it so many times. What? Okay, what about the k value, the plus 1? Shifts up 1. Okay, so let's do number 5, and you guys can do the other 2 on your own later. All right, what's the parent function for number 5? Just 2 over 3? X to the power of x. So there's the parent. Do I have an a value? Yes, and this is the one that gets a lot of people whenever it comes to quiz time. Does negative 3 mean that you are compressing? No. But it's less than 1.
It's greater than 1.
What's greater than 1?
Greater than 1 to negative than 2.
There you go. So the negative is its own transformation. That's what causes the reflection. But you can reflect and stretch at the same time. So if you ignore the negative, the 3 value is bigger than 1. So what you're doing is you're stretching by 3, but in the negative direction. That's what that means. Now, what if it said negative 1/2? What if it said negative 1/2 instead of negative 3?
It would reflect, but compress.
Yeah, then you would compress in the negative direction. Okay, last 2. The h value says plus 1, so what does that do? Left 1. And then minus 2 is your k. Shifts down 2. All right, so we good at identifying transformations for exponentials. All right, let's jump down to the bottom with some logs. Do the same thing. I don't know why the y isn't on here. I could have sworn I put it, but I guess I didn't. So it should say y equals. That bothers me. All right, so let's start with number 7. What's the parent function? Log base of just the x. That's the parent. So everything else is a transformation. Do we have an a value? Anything in front being multiplied? Is anybody counting? What was that? 7 sneezes. Wow. Bless you. All right, so there's no a value. Do we have an h value? Do we have an h value?
Yes.
What's the h? Where are you looking? We're on 7.
I thought you were on 8.
No, we're on 7.
1.
It's 1 because the 1 is changing your x in the inside. But we inverse it, so I translate where?
Right.
And then we have a k value of plus 2, which is on the outside, so it's going to shift
Right.
All right, let's do number 8. What's the parent? Y equals what? Okay. I don't know. Where are we at? Oh, yes, it is. Thank you. Did we save right? Wow. Sorry, guys. That's on me. I should have fixed that.
It's left.
It is left. Thank you for whoever caught that. All right, number 8. Parent function is log base 2. Do we have an a value? Yeah, it's 4. So what happens if you multiply by 4? It's going to stretch you. Stretches by 4. Do we have a h? Yeah, there's something inside. So the minus 3 is going to make you what? That one's going to go right because it's negative. Do we have a k? No, because there's no value on the outside being added or subtracted. So we did not shift up or down. Okay, last one, and then we'll start graphing and doing domain and range. Okay, number 9. The parent function would be log base 3 of x. Do we have a value?
No, there's negative.
So if we do have an a, it's -1. So it doesn't make you stretch or compress, but what does it do? Reflects. So the negative just makes you reflect. The plus 2?
Left. 2.
And the plus 3. So I think we got the hang of it now, hopefully. We all know where a, h, and k belong in the function. Alrighty, so go ahead and pick one of these other than the one that we did, number 3. So 1 through 6, pick one. 5? Alright, so number 5. Flip it over. This one was number 3. We already did that yesterday. So we're going to do number 5 right here. Alright, so we know that the parent function for exponentials, what do we say the parent approaches as it gets negative? It approaches 0. But if we ended up shifting it down 2, is your asymptote still going to be at 0? Where's it going to be? It should be at -2. So I know ahead of time that my asymptote should be here at -2. And if you didn't know that, it's okay, because when you go to your table in your calculator, you'll see how the numbers get closer and closer to -2. All right, what does number 5 say?
1 equals -3.
2 over 3. And then hit the caret right here below the clear symbol to get to your exponent. X plus 1. And then hit the right arrow to get down from your exponent. -2. All right, hit graph to get a sneak preview. That's what it should look like.
You're amazing.
Huh?
You're amazing.
Why?
You're a teacher.
Oh, thanks, guys. Bless you. Anyway, all right, so do you see that the asymptote is at -2 now? Everything got shifted down 2? Okay, why does it look like it's upside down, though? Because they reflected. Very good. So let's go to the table. We have all the way from -10 to 10 to graph on our x-axis. Look at these numbers, though, right here. Look at your y's. Like I said earlier, if you didn't know where your asymptote was, look at the numbers. What are they getting close to? To -2, because -2 is your asymptote. They keep approaching it. And eventually it's going to say -2 because of how close it is. But it's really not. It's not at -2. It's just super close. Because look, they run out of room of putting all those zeros. They can't put all those zeros in this little space. So it's just super close to -2. All right, let's start on the positive side. Positive 10 is the furthest we can go. So we got -2.035. Which is a little bit below, so practically at -2 right here. It's all about estimation, Abby. So scroll up some more. I'm gonna find one that's a little bit further off than that. So 3, -2.6. Keep going. 0, -4.
Like 2.9. Also.
-1, -5.
Wait, no, 2.9.
And -2, -6.5. And this is probably the last one I can graph before it goes off the grid. because that one's further off the grid. So we see the curve happening, right? As it goes down, it's going to negative infinity, and as it's going up, it's approaching that asymptote right here. They start just gradually going towards the negative 2. So just connect the dots, and you have it graphed. So right here was our asymptote. It will never cross the y value of negative 2. Question on how to graph this one. Okay, so let's do domain and range. For domain, remember we go through the x. How far to the left will the x values go? Do they stop here? No, they're going to keep going to the left to negative infinity. How far to the right? Positive infinity. So my domain for number 5 uses all real numbers. Negative infinity to positive infinity. Okay, what about the range? Is it going to use the entire y-axis? No, because we had an asymptote. Go ahead and flip it over, and now let's look for our range. So when you're doing range, you want to go to the very bottom of the graph. How far down? This isn't the furthest down it goes. How far down does it go? Negative infinity. So negative infinity is the lowest. What's the highest? But can I equal negative 2? So what do we use when we approach negative 2? Parentheses. Very good. So we go from negative infinity to negative 2 with a parenthesis since you're approaching. Okay, any questions on how we found our domain and range for number 5?
So we don't have to write like that you pick up after negative 2 because you don't.
No, because you don't. Because there's nothing above the negative 2, right? Like it just approaches negative 2 and that's the graph.
But so
The only ones that we've done in this class that involve unions would be rationals, but that's because you have an asymptote and there's another section of the graph.
but the y-asymptote you can equal them, right? In some cases.
No. With rationals sometimes, but that's because they can cross it. With these, they won't. Because I showed you earlier with the fractions, this is what's happening. So on this one, you will literally never get to that number. It just keeps getting closer and closer to it. So it's kind of the same concept with the negative 2. It's going to keep getting closer to it, but you'll actually never get to it. Yeah. Yeah. All right, so x-intercept. Do we have an x-intercept? So I look at the x-axis. Is it ever going to cross the x-axis? So what do you put if it doesn't cross it? None. What about the y-axis? Do we have a y-intercept? Where's the y-intercept at? 0, negative 4. So for x-intercept, we put NA or none. For y-intercept, it crosses it at 0, negative 4. Okay, the last thing I want you to label is what was the asymptote we said we had? Y equals negative 2. Make sure you give me the equation because it's the y value that you're approaching, not the x. The y's approach negative 2. And that's it for that one. All right, pick one of the logs at the bottom. Number 8. All right, let's go graph 8. Number 8. So go to y equals. Remember, what type of inputs could you not have with logs? Negative. So we had an asymptote at 0 for x, but what happens if I move this graph left or right? Is that asymptote going to move? If you move it left or right? Yes, it will. So the same thing might happen with this one. What do we have? 4 log base what? Anything on the outside? No? Okay. So does it look like the asymptote moved from 0? Where did it move?
4.
Close. It's not 4. Didn't we translate it right? 3? So then where's the asymptote at? Probably 3. So logs are really easy to find the asymptotes. You want to know why? Because look, go to the table. Oh look, it says error everywhere. I wonder where that asymptote was at. It was at 3. So with logs, you can find your asymptote very easily by looking for the very first error because that's the value that you cannot equal. It will just approach the 3 because at 3 is what causes you to have a negative input. So let's graph our asymptote at x equals 3 or y equals 3? X equals 3, which is a vertical line. Let's go to 3. Here's the asymptote. That's the asymptote. Remember, because logs are switched. And we have the very first coordinate that we can graph is 4, 0. Keep going. 5, 4. Now this one's going to look a little weird because it got stretched out. So 7, 8. And then it's going to probably go off the grid. Oh, no. 8, 9.2. Now it goes off the grid. All right, but what was happening here? Does it stop there at 4, 0? No, because there's numbers that exist in between 4 and 3. There's numbers that exist in between 4 and 3. And what are those numbers going to do? It's going to make me go down towards the asymptote. So as I go down, we're approaching this asymptote, it's going to hug it. It hugs it. And then up here, it just keeps increasing to infinity like that. So it looks really tall compared to the parent right here. But the reason why it's so tall is because we stretched it by 4. So it's going to look tall. All right, questions on how to graph a logarithm. Okay, so what's the domain? Is the domain all real numbers? Do I go left forever and right forever? No. What's the furthest to the left we can go? 3. Do I equal 3? No. How far to the right can I go? Okay, so domain is, wait, which one is this? 8, right?
3 infinity.
No brackets because we can't equal. Yeah. Aw, Kayla's sleepy. Okay, now let's do range. How far down will the y's go? Okay, how far up? Positive infinity. Okay, x-intercept, y-intercept. Yep, it was at 4, 0. And y-intercept? Why was there no y-intercept? So the x-intercept took place right here at 4, 0, because that's where it's crossing. And it will never cross the y-axis because we have that asymptote that it won't even pass. So we don't have a y-intercept. Okay, last thing is, what was the asymptote for this? What was 3? All right, that's it.
So there's no. Okay, yeah, there is.
What?
Never mind. I was about to ask you.
The asymptote
No, yeah, the asymptote.
or the intercept?
I didn't really hear you say x-intercept. That's distinctly put it down.
Yeah, I put x-intercept and y-intercept. So the x-intercept crosses right here at 4, 0, but it will never cross the y-intercept since we have this asymptote here. So we put none for y-intercept. And we do know that there's an asymptote here, but it's at x equals 3 because their x is, it will not ever get to x equals 3. That's why it said error.
It's just my full computer and that's all.
All right. Okay, so one thing I just want to point out to you guys. What do we know about the domain for all exponentials? It's all real numbers for the domain. But it switches when you do logarithms. What becomes all real numbers? The range. So to answer your question, will that always be the case? Yes. All right, go ahead and pack. Tomorrow we're going to practice and you'll have a little baby quiz 1 graph.